So today we're going to talk about rational exponents, which are essentially exponents in a radical form or as fractions that we're converting to radicals. So the first thing we need to discuss is what is exponential form and what is radical form, because they're going to have us working back and forth between the two a little bit. So the first one is 25 to the 1/2 power. So what is this? This is exponential form. So it's a number with an exponent. And we need to make this into radical form. So the easiest way that we can learn to do this is using the 1 over b to the second, just the definition of that. So what that's telling us is if we have 16 to the 1/2, we're taking this 1, the numerator, and we're moving it here. And then we're taking the 2 and we're putting it here. And that's going to work for most of the exponents that we work at with that are fractions throughout this. So the funny thing about this is we know that the square root is already using the 2, so we don't really need a 2 here. And then 16 to the 1 is still 16, so we don't really need the 1 here either, right? So basically the square root of 16 using this 1 over b squared form is 4. So now let's look back over here at 25 to that 1/2 power. So again, we're taking 1 and putting that after the 25. We're taking the 2 and putting that outside of this radical. We don't really need either of them, so I'm going to come in here and just go and erase them real quick. So the square root of 25, which is 5. And that's using this 1 over b squared definition. We can do the opposite also. If we have the square root of 18 and we need to write it in exponential form, we can take the power next to the 18, which is 1. We can take the square root, which is a 2, and then we can write our whole number here. So we can rewrite this in exponential form as 18 to the 1/2 power. Next, we're going to look over here at the nth root. So that's solving something that's to the nth root. Remember, the nth is just kind of like to any root that we decided to be at the time. N is representing a value kind of like x. So we have a to the n equals b. If that's the case, then when we rewrite this, we're going to put n here, square root of b to the a equals a. Sorry, I'm getting ahead of myself here. So using numbers, we would do 2 to the 4th equals 16, right? Because we know that that's true. And we could rewrite this as the 4th root of 16 is equal to 2. Or we can have the cube root of 27, this 3 right here. And we know that the cube root, or that 27 cubed is 3, 3, 3. So 3 cubed is equal to 27. Now we can pull this out and solve and know that the cube root of 27 is also equivalent to 3. And that's why we need to use the nth root. Moving on to this 1 over b to the n. So remember, we're going to solve these just like we did 1 over b squared, but now that n might be a number that isn't 2. So we have 8 to the 1/3 power. So just like before, we're going 8 to the 1st, but then we're going to use the cube root instead of the square root. Now remember, there's this button on your calculator that looks like this. And basically this X right here is saying that any number you want that isn't 2, we can plug in here. So now we're going to write this. We would write this 3 root 8. And that would solve it for us on our calculator. Again, this one right here that we don't really need, I'm just going to erase it. So we have the cube root of 8. We know that 8 is 2 times 2 times 2. So 3 2's under there would give us the cube root. So the cubed root of 8 is simply 2. We can do that with any other number that we put under there. We could use 1,296 to the 1/4 power. So we're going to write that as the 4th root of 1,296. Again, we don't need this little 1 over here, but it's imaginary. 1,296 to the first power is still 1,296. So what can we multiply 4 times to get 1,296? A little prime factorization will show us that it's 6 times 6 times 6 times 6. So 1,296 to the 4th root is 6. Now let's take what we've learned and apply that with numbers that aren't 1 on top. So now we're going to do this b to the m over n. So any number is m and any number is n, and we can solve this. So let's take 8 to the 2/3 power. We can rewrite this as 8 cube root, because we're taking our denominator, and then we're going to square all of this. So the cube root of 8, 3, 2 times 2 times 2. We've done this already. So the cube root of 8 equals 2. Now we need to square our 2 because of this 2 up here. So our 2 squared equals 4. So 8 to the 2/3 power is equal to 4. Easy enough, right? One last thing I wanted to talk about is this power property of equality. What this is telling us is when our bases are the same, then our exponents are going to equal each other. So if we have 5x equals 5 to the 3, our x equals 3. Because the only way this is true is if 5 to the 3rd equals 5 to the 3rd, because we have this equal sign between it, and that's the only statement that's true. If we had any other number for x, then it would not equal each other. So we have x to the 3rd, or x equals 3. We can also use this to solve algebraic expressions. Think about this. If we have 25 to the x minus 1, and that equals 5. What can we do to 25 to make that a base 5? Well, that's 5 squared, right? So 5 squared to the x minus 1 equals 5. Using our multiplication of exponents property, we know we can multiply 2 times x minus 1. So in order to do that, we have to distribute that 2. So 5 to the 2x minus 2 equals 5. So now we have the same base, so we can just use our exponents to equal each other. So 2x equals 3. Divide both sides by 2. And we get x equals 3 over 2. So we just took something that we learned so long ago, solving algebraic expressions, equations, and now we're applying that to exponents. See how everything kind of builds on each other? And this skill is so important to know. We can also plug back in 3 over 2. Do 25 to the 3 over 2 power and see, or 25 to the 3 over 2 minus 1 equals 5, and make sure that that equals 5, because we would plug 3 over 2 back in up here for x.